Okay, 4.7, we're going to look at dividing. So we have to think back to our rule for dividing exponents, that when you divide exponents, let's say x divided by x to the fifth divided by x to the third, you subtract. And so 5 minus 3 would be 2. But say you had x to the third over x to the fifth on the bottom, we're still going to subtract and say 3 minus 5 is x to the negative 2. But remember, we can't leave a negative exponent. So anytime you have a negative exponent, it needs to move to the bottom and become positive. So we're going to think about both of those rules as we're working through these. But when we look at this first one, it's saying take all three of these things and divide it by 5x. And so just so you can kind of see what we're doing a little bit better, I like to write the 5x underneath. So we're going to divide this one by 5x, this one by 5x, and then this one by 5x. So we're going to divide the numbers, subtract the exponents. So I say 50 divided by 5 is 10. This is like a 1. x3 divided by x1, 3 minus 1 is x2. Then a minus. 15 divided by 5 is 3. 2 minus 1 just leaves 1x. And then 20 divided by 5 is 4. And you see 1 minus 1 would leave 0 x's. So that's just our answer. So we divide the numbers, subtract the exponents. So this next one, we've got what, 5 terms here, and we're going to divide them all by negative 3x squared. And again, you don't have to do this. It just kind of helps your brain see it lined up. So I'm going to write this negative 3x squared under each one of them. And then you got to think about your signs. So the signs are alike, so it's positive. 39 divided by 3 is 13. And then x4 divided by x2, 4 minus 2 leaves 2. The signs are different, so it's negative. 12 divided by 3 is 4. 3 minus 2 just leaves 1x there. Then the signs are alike, so it's positive. 9 divided by 3 is 3. And here, 2 minus 2 leaves 0 x's. So at this point, you might want to think, okay, we're descending, so we're going to start going to the bottom of the fraction, because most of the time they're in descending orders, not all the time. But so when we look at this next one, the signs are alike, so it's positive. But here, 7 divided by 3, you can't really divide 7 by 3, so we're just going to leave it 7 over 3. But then with our exponents, we have 1 minus 2, let me write this in a different color, is an x to the negative 1. But remember, you can't have a negative exponent, so that means that x is going to move to the bottom. So when you have a negative exponent, it moves to the bottom and becomes positive. This next one, the signs are different, so it's negative. And you see 3 won't go into 5. There's no x's to simplify, so you just leave this 5 over 3x squared. So what I was talking about, noticing the pattern, you see it goes 3, 2, 1, 0, and then it goes to the bottom 1, 2. So if you're in descending order, after 0, it's going to move to the bottom of the fraction. Okay, this next one, again, we're just dividing all these by 3a. So here, 12 divided by 3 is 4. It's like a 1. 7 minus 1 is a to the 6. The negative comes down. 6 divided by 3 is 2. 5 minus 1 leaves a to the 4. We have a plus. But right here, 3 will go into 3 one time, but do you see that 1 is going to be left on the top, and that a is going to be left on the bottom. And some people say, well, what if you did the 1 on the bottom and not on the top? That's fine. You still have a 1a down there, but you have to show that a is on the bottom by leaving it 1 over that a, because the a needs to stay on the bottom. Okay, this next one's the same problem, just written a different way. See, it's saying take this whole parentheses and divide it by this one term right here. So that really just means divide this by 10x squared y3, divide this by 10x squared y3, this by 10x squared y3, and this by 10x squared y3. So you just start at the beginning and just start dividing. 90 divided by 10 is 9. 6 minus 2 is x to the 4th. 3 minus 3 leaves 0 y's. Then we have a negative. 60 divided by 10 is 6. 5 minus 2 is x3. 4 minus 3 is y1. Then we have a plus. 40 divided by 10 is 4. 4 minus 2 leaves x2. 5 minus 3 leaves y2. And then the last one's a minus. 10 divided by 10 is 1. 3 minus 2 leaves x1. And 6 minus 3 leaves y3. So that one didn't have any negatives. Okay, now all of these were divided by a single term. And so that means you can do that quicker way of dividing, because if I ask you what's 844 divided by 2, most everybody can do that in your head, because you're just saying 8 divided by 2 is 4, 4 divided by 2 is 2, 4 divided by 2 is 2. When you're dividing by a single term, you can take each digit and divide it by that number. But if I ask you what's 256 divided by 21, you can't do that quickly because it's a 2-digit number. And this is when we use long division. So before we do algebraic long division, I want to go back through how to do just basic arithmetic long addition. It might be a long time since you've done this. And so when you're doing long division, remember you take this term out front and you say, how many times will 21 go into 25? So you're thinking, how many times will it divide into that? And it'll go 1 time. So first you divide, then you multiply and say 1 times 21 is 21, and then you subtract. 25 minus 21 is 4. You bring the next number down, and then you do it again. How many times will 21 go into 46? It'll go 2 times. Then you multiply. 2 times 21 is 42. And then you subtract. And you could keep going on if you wanted a decimal. Or if you're writing it just as a mixed number, your answer would be this number up here, 12, with the remainder over the divisor. And so we're going to use those same steps, except for now we're dealing with algebra. So for this problem, we're going to put the top on the inside. This x squared plus 2x plus 6 goes on the inside, and this x plus 3 goes on the outside. And then we're going to think through the steps we had over here. So first, I'm going to write them down here. First we divided, then we multiplied, and then we subtracted. And you just keep doing that in that order until you're finished with the problem. So let me get a different color pen here. So for this one, we're going to say how many times, so you're looking at x plus 3 in this whole thing, but you really can just look at the first letter and say how many times will x divide into x squared. So you're really saying 2 minus 1 would go 1 time. So you're dividing x squared divided by x is x, just like we put our 1 up here. Now we're going to multiply. The only difference now is you have to multiply that times both things. So I have to say x times x is x squared. X times positive 3 is a positive 3x. So we multiplied. And then we're going to subtract. But in algebra, subtraction really means to change the signs. So I have this stupid little saying, but hopefully it helps, that when you draw the line to subtract, you change both signs. So I'll write it here. Draw the line, change both signs. Because that's really what subtraction means. Which this is always going to cancel out because you made it to where they canceled out. Just like here, the 2's would cancel out. And so really the only place you have to do any really math is right here, where you say a positive 2 and a negative 3 is a negative 1x. You just do your sign rules right there. Then you bring down the next term, and we're going to do it again. So negative 1x divided by x, do you see the x's would cancel, leaving me a negative, whoops, let me do that in blue, a negative 1. So negative 1x divided by x is negative 1. And then you're going to multiply the negative 1. So negative 1 times x is a negative 1x. Negative 1 times positive 3 is a negative 3. So I did the multiplication. And then we're going to draw the line and change both signs. They were negative, so now I'm going to make them positive, which means that'll cancel out, which if it doesn't cancel out, you did something wrong there. And then 6 plus 3 is 9. So my answer is, what's on top there, so let me put it up here. So my answer is x minus 1 with a remainder over the divisor. So then it's plus 9 over x plus 3. That's a plus right there. If that was a negative 9, then it would be minus 9 over x plus 3. Now, I know these are difficult. I know I say it all the time, though, but you got to practice them over and over to make sure that you can do them. So let's try another one. So the top's going to go on the inside, y squared plus 2y minus 4, and the y minus 2 is going to go on the outside. So we're going to divide, multiply, subtract, and then repeat it. Divide, multiply, subtract. And when you get into college algebra, this might be a y to the 8th, and it has 8 different things, but you just keep doing it until you get them finished. So you just divide, multiply, subtract, divide, multiply, subtract. So y sub 2 divided by y sub 1 is just a regular y, just a y1. Then we're going to multiply. Y times y is y squared. Y times negative 2 is a negative 2y. Then we're going to subtract. So when you draw the line, change both signs. That's really what subtraction is, which cancels that out. If it doesn't cancel out, you did something wrong. And then 2y plus 2y is 4y. You just do the sign rule there. Bring down the next term. And then do it again. 4y divided by y. The y's would cancel, leaving you a positive 4. If this was a, well, it was a negative 1 there. So yeah, if it's negative, you bring up the negative. If it's positive, you bring up the positive. And then multiply again. 4 times y is 4y. 4 times negative 2 is negative 8. Draw the line, change both signs, and so this one has a remainder of 4. So your answer is written as what's on top, that y plus 4, and then a plus 4 over y minus 2, your remainder over your divisor. And I didn't do an example with, sometimes this can be 0, and on your worksheet, I think one of them does come out 0. So if it's 0, then your answer is just y plus 4. It doesn't have a remainder. And if it does have a remainder, you just write it over the divisor. So that's dividing. You're now ready for the 4.7 practice problems.